Let's record this for all my wonderful YouTube viewers. Problem number 90 in chapter 16. Two sinusoidal waves. One has this equation, y1 of x and t is equal to 0.3 meters times sine of 4 inverse meters times x plus 3 inverse seconds times t. And y2 of x and t is equal to 0.6 meters times the sine of 8 inverse meters, meters to the negative 1, times x minus 6 inverse seconds times t. So I have these two equations that represent this motion. Y is a height, x is a position, t is a time. And I look at this wave equation, I can see it has some amplitude, 0.3 meters is my amplitude. I've got some kind of wave number. That's the 4 inverse meters, the k. And then I have an angular frequency of 3 inverse seconds. Some questions for you. All of this stuff, this looks really, really complicated, shit tons of letters in there. I can get rid of some of those. I can make things a little bit easier to understand by getting rid of all the units. So this is the same thing as this. 0.3 times sine of 4x plus 3 times t. That makes it, I think, a little bit simpler to see, simpler to understand. The tricky part is recognizing these units. They exist for a reason. So x, what are the typical units of x, of a position? Meters. What's a meter times 1 over a meter?
1. Just 1.
Just 1, unitless. So that gets rid of these units. What's a typical unit for time? Seconds. Seconds times inverse seconds. 1, they cancel each other out, so there's no units there. So the variables, the numbers that you have inside of the sign are unitless. And what are the SI units of angle, of something that you plug into a sign? What are the units here that are technically unitless?
Radians.
Radians. So I went through all this wonderful spiel so that you know when doing these problems, you need to put your calculator into radians. If you do not put your calculator into radians, you will get wrong answers. You will get wrong answers on exams. Because I am telling you to do this, I will not be as generous as I usually am with you getting wrong numbers. If you plug in to your calculator and you give me answers in degrees, I'm going to take off a lot of points. Because I specifically have said, do not do that. Okay, so make sure that your calculators are in radian mode. If you don't know how to do that, today is the day to ask me. I will come around and I will help you when you're doing problems. Okay? Everybody's calculator is a little different, so I don't want to take a ton of time right now to do that for you. But we'll make sure when I give you class time. Okay, so we can do the same thing with the second y2. It's going to be 0.6. I get rid of the units just because they look confusing to me. So I do sine times 8x minus 6t. So these are my two equations for my two wave function positions. These waves traveling along a string. And they want to know what is the height of the resultant wave formed by the interference of the two waves at the position x equals 0.5 at time t equals 0.2. So x equals 0.5 meters, t equals 0.2 seconds. So how do I do this? It looks like a really, really complicated problem when you load it up and start reading it. Any guesses of what I should do?
Just plug it in.
Just plug in the numbers. This is a pure plug and chug. So y1 of 0.5 for x and 0.2 for t. So I plug those numbers in. I get 0.3 times sine of 4 times 0.5 plus 3 times 0.2. So I'm gonna do some calculations. I'm gonna do my 0.3 times sine. I'm gonna multiply out everything that's in that parentheses. 4 times 0.5 plus 3 times 0.2, and I got 2.6. So y1 I got is 0.3 times sine of 2.6. So let me see what sine of 2.6 is.
Is this the part where we change it, the calculator to radians?
That's a great question. I got 0.045. Did anybody else get 0.045? If you did not get 0.045, raise your hand and tell me what you got.
I got 0.15.
You got 0.15?
Oh, yeah. Sorry, I didn't multiply by point. I multiplied by 0.3. Never mind.
I just want to know what you got for a sine of 2.6. Other people are getting 0.51?
Yeah.
Did anybody get 0.045?
I got that.
You got 0.045? Good. Okay. How many of you got 0.045? Raise your hands. Okay, put your hands down. How many of you got 0.51? Raise your hands. Okay. Can you so you got the same thing as I did. Can you tell me what we did wrong? Look up there. Super tiny little letters. Degrees. Convert your calculator into radians. So typically you hit the little button that says mode. I would do radians, and then I go back and I do sine of 2.6, and I got, oh good, 0.51. Okay, so make sure you're in degrees. If you're getting 0.045, then you are in radians. Convert to degrees. Make sure you're in degrees. So y1 will be 0.3 times 0.51. Maybe I just said the opposite. Did I say the opposite? Yeah. Make sure your calculator is in radians, not in degrees. Sorry to the Indian guy in Alaska that's watching this and is very confused now. Y1, so 0.3 times 0.51. I got 0.15. Yeah? Okay, let's keep going. Y2 of 0.5 and 0.2. Ah, what are the units of y? Y is a height.
Meters.
Meters. So y2, I'm going to do 0.6 times sine of 8 times 0.5 minus 6 times 0.2. So 0.6 times sine. Multiply my numbers out. 8 times 0.5 minus 6 times 0.2. So I need to do sine of 2.8. And to make sure my calculator is in what mode?
Radians.
Radians, 0.6 times sine of 2.8. And I got 0.2. Anybody else get that?
Yes.
Yeah?
Yes.
Okay. So the total amplitude is going to be the sum of these, y1 plus y2. 0.15 plus 0.2 equals 0.35 meters. Great. That's how you do problem 90. Problem 91 is almost the exact same thing, except different numbers in different equations. Same approach. Plug and chug. Bless you in the back.
What number?
This is
Okay.
number 90, and you are assigned to do number 91. Any questions about this? Any questions at all?